The first thing that we're going to do is to click kite, and then we see that these are all the parameters that is uploaded for this kite well. Of course, if you can edit the data one by one here, or if you want to edit all the data inside of a given project, you can click this edit all icon up here to the right. Okay, that's where you can just edit stuff in the mass upload type of manner. If you go back to the kite well, you see that we've actually uploaded in the mass upload file all this data, PVT, production, and wellbore configuration data. What we have not done is to do any analysis. So what we'll do is to start from the top and move our way downwards. And we'll start with PVT. So if I click PVT here, or if I click PVT here, it brings me to the exact same place, which is this fluid definition module. What you'll see here in the fluid definition module is that the fluid definition, if I open this input card right here, and that's what we call an input card, and that input card holds input information. And the way to edit that is to click this icon right here, which is a square with a pencil inside it. So if you click that, you see that we get an option to pick different methods. That's GOR, GOR and API, GOR saturation pressure. I can use separated compositions if I like, or I can use the full fluid composition. So here you try to use the PVT information that you have readily available to you. For this particular well, the only thing that I had available was the initial producing GOR. So I'll go ahead and use that. And the initial producing GOR is 750 scuffs per barrel in this case. Then I go ahead and click save. The reason why I picked 750 was again that this is, at least looking at the production data, this is most likely an undersaturated oil. And an undersaturated oil will have a constant producing GOR for a little period of time. So if I just either in the numerical model look at the producing GOR, you see that the producing GOR is around 750, so plus minus 50, so down to 700 and maybe up to 800 here. And you can also toggle this on a Kuhn plot to see that value. On a Kuhn plot, it's typically closer to 800, I guess. But 750 is in this case my educated guess. But you could also check that in the production data and double click the GOR. And the GOR will then provide you with 750 as a good initial guess. At least that's my interpretation of this case. And if you go back to PVT, what you can see there is that the associated phase envelope indicates that this is a highly undersaturated oil. It's a big difference between the initial reservoir pressure and the phase envelope. And inside here, there's a lot of two-phase stuff. And you also see that this is a oil because this is hitting a bubble point with pressure depletion. The tables have already been created here. So what the PVT module does is that it uses the GOR and an equation of state model in the background, and it predicts a full reservoir fluid composition. And with this reservoir fluid composition, it creates tables that you can then look at on plots here, or of course download in any third-party tool that you might need. And in the software, if you want to do analysis going downwards from here, you don't have to even think about the PVT. This is what you did to get your PVT up and running. And the PVT will be used everywhere where PVT is an input, so flowing bottom pressures, flow material balance, analytical RTA, numerical modeling, gas EOR, etc., etc.